50. Read each scenario and write an equation that expresses the percentage relationship in that scenario. Do not solve the equations. Part A. A jacket's price tag is $200, but you will need more than that to buy the jacket because there is a sales tax of 8% that is added to the price. What is the total price of the jacket? P. The price starts at $200, and then sales tax is added. Sales tax is 8%, so 0.08 times 200 would be the amount of tax that's added to the price, and that equals P. Part B. You paid $23.85 for a meal, which included a 6% sales tax. What was the cost of the meal, C, before the tax was added? This one is the reverse of Part A. This time we're starting with C, the cost of the meal, and then you would add sales tax to it. And the sales tax is 6%, 0.06. It's 6% of the cost of the meal, so 0.06C. And when you add those two together, you get how much you paid, $23.85. Now, admittedly, it is really common to take $23.85 and multiply it by 0.06 and then do $23.85 minus that amount. It's very tempting to do that, but when you do that, you're actually changing this $23.85 by 6%, and that's not how the 6% sales tax is calculated. It's added to the actual cost of the meal. So this equation models a scenario, whereas this other one is tempting. It's a common way to write it, but it doesn't model this scenario. Number 51. Answer each of the questions in the previous scenario. I can do that in the space above. C above. In part A, 0.08 times 200 is 16. 200 plus 16 is equal to P. And so P equals 216, and that's dollars. That's the total price of the jacket after sales tax. Part B, C plus 0.06C can be combined as 1.06C, and then to solve that equation, divide both sides by 1.06. C is equal to 22.5, which is $22.50. That's the cost before the sales tax was added. 52. In 2013, Dee's house was worth 112% of what she paid when she bought the home 3 years earlier. By what percent did the value of Dee's house change during those 3 years? If the house has increased and is now worth 112%, well, it started at 100%. So 112 minus 100 is a 12% increase. And then you could write increase just to clarify that. Part B. Lou's house is worth 85% of its purchase price 5 years ago. By what percent did the value of his house change during the last 5 years? If it started at 100 and it went down to 85, the difference between that is 15. So that would be a 15% decrease. 53. The price of a shirt is $24 on Friday, but the price increases 22% over the weekend. How much does that same shirt cost on Monday? Well, we're starting with 24, and then you're adding 22% of 24 to the price. That's one way to do this. You could also realize that a 22% increase would make it 122% of its original price. So you can take 24 and multiply it by the decimal form of 122%, 1.22. If you take this approach over here, you can see that $5.28 is the amount that was added, and then the total price is $29.28. In this, you have a single value you can type into the calculator, and it immediately gets you that $29.28 amount. 54. If the value of a car in June of 2012 was V dollars, but the value decreased 8% over the course of the next 12 months, what is the value of the car in June of 2013 written in terms of V? The value starts at V, and it decreases by 8%, so 0.08 times itself. And I'm giving you this scenario because I want you to realize that V minus 0.08V can be combined to be 0.92V, and that in that you can see that if something decreases by 8%, it is now worth 92% of its starting value. 55. On September 16th, one share of Intel stock cost $21. That price was 5% higher than the previous day. Write an equation to express this price change using the variable P to represent the price on September 15th. The starting price is P, and that price goes up by 5%. After it goes up by 5%, it is equal to $21. As we saw in an earlier scenario, it might be tempting for you to say, well, let me go down from 21 to 21 minus 0.05 times 21, but that will not lead to the same result because it's not the $21 that's changing by 5%. It's the previous day's price that went up by 5%. So that's kind of a challenging type of equation, and I'm trying to get you to become more comfortable with that. Part B, make a guess. Was the price on September 15th closer to $15, $20, or $25? All I want you to do is think about if something cost $21 after going up by 5%, could it be $25? No, it couldn't be 25 because the price has to be lower than 21 if it went up by 5% to end up at 21. And then that leaves you either 15 or 20 as your guess. Well, 15 to 21 is a jump of $6. And 6 is more than a third of 15. Well, the price only went up by 5%. That's a pretty small percent. So it couldn't have started at 15. And that leaves us at 20 as our estimate price. Now, before I move on, I want to point out that P plus 0.05P is 1.5P. And we can stop there on this scenario. 56. A percentage change can often be expressed with an equation. There are 3 common types of percentage change scenarios. Write an equation for each type of scenario below. Type 1. The price of a ball increases from $12 to $15. By what percent did its price change? In this one, you know the starting and the ending amount, and you can calculate the percent. There are multiple ways to do this. You can first figure out that 15 minus 12 is 3, and then do 3 divided by the original amount, and that's 3/12. So 3/12 is equal to P. That's also 1/4. It's also 25%, but I'm not really concerned about going farther than that. I just want to look at the structure. Another way you can do this is to say that if you start with 12 and you increase it by some percent of 12, and then it ends up at 15, well, what would be the percent amount? To solve that equation, you would take this 12 and move it over here. So you would subtract 12, 15 minus 12. Oh yeah, there's the 15 minus 12. Then you would isolate P by dividing by 12. Oh yeah, there's the divide by 12 part. So this solution ends up the same as this solution, but we see a sort of a structure here of something increases by some percent and then ends up at a final value. Part B, type 2. Before tax, the price of a ball is listed as $12. The sales tax is 7.4%. How much do you have to pay to buy the ball? You start at 12, and then you're going to add a 7% sales tax, 0.074, and that's calculated as some percent of the 12 you started at. And then after that, that equals your final amount, your final price. Use whatever variable you want there. Part C, type 3. Your sales receipt shows that you paid $12 for a ball. If the sales tax was 7.4%, what was the original price of the ball as listed on its price tag? So let's say the original price is P, and that increased by 7.4%. So P plus 0.074 times the price is equal to 12. And we could also combine that as 1.074P equals 12. So these are your 3 types. Type 1 is where you know the starting value and the ending value, and you want to figure out the percent. Then you know your starting value and the percent by which it's changing. And then type 3 is where you don't know your starting value, but you know the percent by which it changes, and you know your final value. I want you to kind of see these in 3 different categories so you can maybe identify as you're working through a scenario which type you're in. 57 says the most challenging scenario is usually type 3. Go back through every scenario in this section and mark each scenario as type 1, type 2, or type 3. As you go back through the scenarios in this section, you can mark them and then compare your markings with the answer key at the back of this part of the book.